So, good day everyone, I am Cadet Melvin Ola-a. So, for today's video, we're going to calculate the celestial bodies' true bearing and compass error. So, for this video, we're having a three different celestial body which is the Sun, the planet Jupiter, and the star Myrrha. So first, the Sun's bearing and gyro error sa atong i-calculate. So, having the condition, position, north 10 degree 19 minutes and east 123 degree 53 minutes and January 11, 2017. And having a local time of 16 hours, 18 minutes, 25 seconds and the zone difference plus 8 hours. So, you took the sun's bearing by gyro compass which is 243 degree true. And what we're going to do is to calculate for the true bearing and the gyro compass error. So now, we're going to calculate muna sa GMT or the Greenwich Mean Time. Since we're having a local time and the zone difference, then we're going to apply minus 8 since GMT and we're ahead of, our position is ahead of 8 hours. So 16 hours, 18 minutes, 25 seconds minus 8. So we're having Greenwich Mean Time 8 hours, 18 minutes, 25 seconds. So to get the GHA for the sun, we're going to use the date, which is 11 day, 8 hours. And for that 11 day and 8 hours, we're going to use the given table to get the GHA for the sun. So since 11, that is January 10 and 11, so we're going to get trace, that is 11 and 8 hours. So 11, 8 hours, so that would be 298 0.7 for the GHA of the sun. So that's it, GHA 298 degree 0.7 minutes. And for the remaining 18 minutes and 25 seconds, remaining, we're going to use the increments and corrections. Okay, 18 minutes, that's it, increments and correction, and 25 minutes. So ato siyang i-trace 25 seconds, that is 4 degree and 36.3 minutes. So we have applied the thing. So we're going to calculate now. So 302 degree 37 minutes. And for the declination, from the sun, it's for the table, from the first table. So the sun, 11 and 8, that's it. And the declination is 21 degree 45.1 minutes. Okay? And the correction, again, the increments and correction. So 11:25, 18:25, I mean. Okay? For the correction, here it is. No, that's not. For the correction, for the sun, okay, that's it, the declination correction, that is 0.4. And since the declination, as we can see, declination is okay, it is here from the increments and correction. So it is 0.4. So 0.4 is for the correction 0.1. And since the the correction is increasing, the declination, we're going to add also. So that would be south 21 degree 45.2 minutes. So now we're going to forward to the LHA, the GHA plus the longitude. Okay, 302 degree 37 minutes plus 123 degree 53.0 minutes. That would be 426 degree 30 minutes. And we're going to deduct 1 revolution. So that would be 66 degree 30 minutes. So now we're going to use the ABC tables to get the sun's true bearing, and the gyro compass error, of course. So for the A, we're going to use the LHA and the latitude. And since we have the LHA, which is 66 and the 30 minutes, so we're going to use 67 if we're going to round off. Okay, so the latitude is 10, and then that is 66. So 66 here, 66, 0.08. Okay? And that is south. It is because named opposite of the latitude. And then the latitude here is north. So that is south. So for the table B, still we're going to use the local hour angle and the latitude. I mean the declination. LHA and the declination. LHA 67, since we have round off, and then the declination is 21, 45.2 or 22. We can trace 22 here, and then 67, 0.44. Okay, that is 0.44. And always name the same as declination. Since our declination is south, table B result is south also. And for the table C, okay, the last value, we just simply add the A and B since they're having same direction. That's just add 0.52 south. Okay, and for the ZN or the azimuth, I just use this formula, which is 1 divide the C value times cosine latitude, and then the result will be inverse tangent to have the angle. So 1 divide 0.52, which is the C, times cosine latitude 10 degree 90 minutes, and that would be 1.9546, and inverse tangent negative 1.9546, that would equal to 62.91 or 62 degree 54 minutes. And then we have named the azimuth south. It depends on the C. Since C is south, our prefix would be south, and then the suffix would be west. It is because it's stated here if the LHA is between 0 to 180, and since 66 is between 180, that would be west. So south 62 degree 54 minutes west. Okay, for the gyro compass error, we're going to deduct azimuth south 62 degree 54 minutes west, and since south is here and then west, we're just simply going to add 180. So 180 is the half of the circle, and then 180 and 270 is here southwest, so simply add 180 to get the true bearing, which is 242 degree 54 minutes. And for the gyro bearing, we have observation of 243 degree, and then minus to get the gyro error, that is 00 degree 06 minutes H. It is because it states that if the gyro bearing is greater than true bearing, gyro error is high, and if it is lesser than the and if true bearing is greater than gyro bearing, then the error is low. So that's it. And then we're going to proceed to the planet Jupiter. here the position of north 10 degrees till east 123 53 minutes, and then the date is December 1, 2017. The local time 05 hours 20 minutes 21 seconds. Zone difference +8. And then we took the planet's Jupiter bearing by gyro compass. Observed bearing reads 110 degree true. Calculate for the true bearing and gyro compass error. So having a local time 05 hours 20 minutes and 21 seconds, then zone difference +8, and then apply the zone difference, that is 21 hours 20 minutes 21 seconds. So that is yesterday. Since December 1, we're going back before the day. So 30 days 21 hours, we're going to check that for the GHA of the planet Jupiter in the chart. So 30 hours 21 minutes, that is 165 58.5 minutes. And for the remaining 20 minutes 21 seconds, we're going to use the increments and corrections. So 20 minutes 21 seconds, sun planets 5 degrees 05.3 minutes, and then add them all to get the GHA of planet Jupiter, that is 171 degrees 03 minutes 48 seconds. Okay, so for the declination, we get that here in the Jupiter since December 30, 21, that is 10.3 minutes. And for the correction here, it is declination 0.2, and then we get here 0.2, the planet 0.2, that is 0.1, and then since it is since the value is increasing, we're going to add the difference in the declination. So south 14 degree 10.4 minutes. So for the LHA, we just simply add GHA and longitude. So that would be 294 degree 56.8 minutes. And now we're going to use the the table ABC. So for the table A, we use the LHA and the latitude. The LHA is 294 or 295. 295 here. 295. And then the 10 here, that is 0.08. And south, since opposite of the latitude north, so south. And for the B, we use the declination and the LHA. So the declination here is 14. We have 14 here, 14, and the LHA is 295 here, 295. That would be 0.28. Okay, 0.28. And that is south. It is because mag-base ta sa atong declination na south. And for the C, we just simply add them both, A and B, that is 0.36 south. And for the azimuth, we use the formula, and that results to 70 degree 29 minutes south and east. It is because south depend on the name of the sea. Okay? And then east, it is because the value of LHA is between 180 to 360 degree. So east. And then now, apply zone azimuth south 70 degree 29 minutes east. So that is south and east here. And then minus 180 degrees since the half of the revolution. That would result to our true bearing 109 degree 31 minutes true. And for the gyro bearing na observation is 110 degree. So now we're getting our gyro error, which is 00 degree 29 minutes H, since the gyro bearing is greater than the true bearing. So now let's proceed to the last celestial body that we observe, which is the star Mirfa. Okay, Same position, and then different date, which is December 5 local time, different 03 hours 32 minutes 57, and then plus 8 zone difference. And we took the star Mirfax bearing by gyro compass, which is observed bearing reads 320 true. Calculate for the true bearing. Okay, so for the GMT, we have applied plus 8, so that is the day before December 5, which is 04 day 19 hours. For the GHA of the star Aries, 4 and 19, 358 for 6.7. Okay, so for the increments and correction, 32 minutes 57 seconds. 32 minutes 57 seconds. That is 8 14.3. 8 57. Yeah. That is 8 15.6 since Aries 15.6. So add them, that would result to 007 degree 2.3 minutes. And for the SHA sidereal or angle of the star Mirfax, that would be here. Mirfax, that is here, Mirfax, that is 308 35 35.5. And then we would add the GHA of the Aries and the SHA of Mirfax. That would be result to GHA of Mirfax 315 degree 37.8. And the declination, it is still the same, north 49 55.4, since we get it here. Okay, so now let's proceed to the LHA. LHA, we're just going to add GHA and the longitude. That results to 79 degree 30.8 minutes. And for the table A, we use the LHA and the latitude. LHA is 79, that would be 80, and then 10, 80, that is 0.03, and that is south because opposite of latitude, north. And then for the table B, LHA 80 degree here, and then 10. I mean, the declination is 49. 1.18. Yeah. No, that is 50. Okay. So 50 and then 80 LHA 1.21. So north, it is because we're basing it to our declination north. Okay? And for the C, we're going to subtract A and B, since B is greater than A, then minus, that is 1.80 north, and we're using the north, it is because B is greater than A. So for the azimuth, we still use the formula, and now we're getting north 40 degree 44 minutes west. Okay, and for the zone, the true bearing, no, northwest, we just simply minus 360, that would result to 319 degree 16 minutes. And the gyro bearing observation is 320. Our error would be 0 degree 44 minutes H, since gyro bearing is greater than true bearing. So that is all for today's video. Thank you and God bless.